Here I have a wee electroscope. A little bit of gold, picks up a charge, and it repels away from the other side here. So these two bits have got the same charge and they're repelling each other. And at the moment I've charged it up positive. So the plate on the top here, I'm careful not to touch it. The plate on the top here has got a positive charge. It transfers down here, pushing the two plates apart. Now, I shine white light on this, regardless how bright it is. There's no discharge, there's nothing discharging from here. I do the same again, this time with a UV lamp. So I'll illuminate this with a UV lamp and still nothing. We're not discharging this. And this is because it's got a positive charge on it. If I tap it and remove the charge, and this time I'll charge it up negatively. So, here we go. I've dumped some electrons in this from my finger. So this now has an overall negative charge. There's extra electrons on this system. It's an isolated system of the plate and the gold leaf here and a wee bit of steel, I think it is. So, I'll bring the white light in again. Shine the white light in on it. No effect. Right. Bring the UV lamp in. It's quite a high energy UV lamp. There's the switch, there it is. When I switch it on and illuminate this, you can see the gold leaf falling. Didn't do that with the white light. So, what do we think about why that is?
Yeah, no weird white light, mixture of lots of different photons, but here we've got a red photon which doesn't have enough energy to knock the electron free. It interacts with it, but it doesn't give it enough energy to knock it free of the surface. However, if I switch to a UV photon, it's got more energy, so when it interacts with the electron, not only does it give it enough energy to knock it free, it also gives it some kinetic energy. So, interacts with it, knocks it free, any balance is given to the electron as kinetic energy. This time we're looking at a positively charged electroscope. The photon of UV light coming in does have enough energy to knock the electron free, but as soon as it's free, it's pulled back to the positive plate, so the electrons can not be ejected, so we're not losing the charge from a positively charged electroscope.
I'm going to charge up the electroscope to a negative charge. Here we go, a negative charge on the electroscope. I'm going to do exactly the same as I did before. White light on it. No effect. And the UV lamp on it. Now the last time you saw that the UV lamp discharged this, but I'm illuminating this. The UV lamp, if I switch it on. And this time look, there's no effect. It's not discharging it. Even although this is a negative charge, still not discharging this. We're not removing any of the electrons from the surface. The reason for this is the first time I did it, I had this little plate sitting on the top. Now, this is a zinc plate, and the work function of zinc is such that the white light doesn't have enough energy to knock the electrons off, but the UV lamp does. This is now a steel plate. Now, the steel plate has got a higher work function, which means even the UV light doesn't have enough energy to knock electrons free.
So let's see if we can make sense of this work function. This is the energy needed just to knock the electron free. So we've changed to cesium this time. Now the cesium's got a very small work function, so it's not that difficult to knock the electron free. So if we use this one, it's a photon that's got very low energy. So it interacts with the electron, but doesn't give it enough energy to knock it free. Now there's this one at the threshold frequency. The threshold frequency It's that frequency that just gives it enough energy to reach surface, but it has no kinetic energy beyond that. Lifts it up, not enough to knock it free. And then if we give it some extra energy, a photon with higher energy, lifts it free and gives it some kinetic energy. Clears the work function, and any extras given is kinetic energy.